Hi all, have a good day. I am K. Surya, working as Assistant Professor in the Department of ECE at SNS College of Technology. So in this video, let us see about BJT and several regions of operation in the BJT. So the DC supply is provided for the operation of a transistor. This DC supply is given to the two PN junctions of a transistor, which influences the actions of majority carriers in these emitter and collector junctions. The junctions are forward biased and reverse biased based on our requirement. Forward bias is the condition where a positive voltage is applied to the p-type and negative voltage is applied to the n-type material. Reverse bias is the condition where a positive voltage is applied to the n-type and the negative voltage is applied to the p-type material, as we know already. Next we will see about transistor biasing. So the supply of suitable external DC voltage is called biasing. Either forward or reverse biasing is done to the emitter and collector junctions of the transistor. These biasing methods make the transistor circuit to work in four kinds of regions such as active region, saturation region, cutoff region and inverse active region. So active region is the region in which the transistors operate as an amplifier. In the saturation region, the transistor is fully on and operates as a switch such that the collector current is equal to the saturation current. And in the cutoff region, that is the region in which the transistor is fully off and the collector current is equal to 0. So here is a table which shows the different biasing conditions for emitter, collector and the region of operation of each. So in the emitter junction is forward biased and the collector junction is also forward biased, then it will operate in the saturation region. When emitter junction is forward biased and collector junction is reverse biased, then it will act in the active region. When the emitter junction is reverse biased and the collector junction is forward biased, the transistor will act in the inverse active region, and when both the junctions are reverse biased, the operation will be in the cutoff region. So first we will see about the active region. So this is the region in which the transistors have many applications. This is also called as linear region. A transistor, while in this region, acts better as an amplifier. So here in the diagram it is shown. So here the current IC will be equal to beta into IB. So this region lies between the saturation and cutoff. The transistor operates in the active region when the emitter junction is forward biased and the collector junction is reverse biased. So in the active state, the collector current is beta times the base current. So IC is equal to beta into IB, where IC is equal to collector current, beta is the current amplification factor and IB is the base current. Next one is the saturation region. So this is the region in which the transistor tends to behave as a closed switch. So the transistor has the effect of its collector and emitter being shorted. So the collector and the emitter currents are maximum in this mode of operation. The figure below shows this. So the transistor operates in the saturation region when both the emitter and the collector junctions are forward biased. As it is understood that in the saturation region the transistor tends to behave as a closed switch, we can say that IC is equal to IE, where IC is the collector current and IE is the emitter current. Next one is the cutoff region. So this is the region in which the transistor tends to behave as an open switch. So the transistor has the effect of its collector and base being opened. So the collector, emitter and the base currents are all 0 in this mode of operation. So this is shown in the figure here. So here we can say the transistor operates in the cutoff region when both the emitter and the collector junctions are reverse biased. As in cutoff region, the collector current, emitter current and the base current are nil, and it is written as IC is equal to IE is equal to IB is equal to 0, where IC is the collector current, IE is the emitter current, and IB is the base current. So let us take up some assessment questions. So first one is, in the saturated region, the transistor acts like a dash. Yes, the answer is closed switch. When does the transistor act like an open switch? So the transistor acts like an open switch in the cutoff region. If the emitter base junction is forward biased and the collector base junction is reverse biased, what will be the region of operation for a transistor? So under this condition, the transistor will operate in the active region. Thank you for watching this video.